Drones have transformed the land surveying industry. Hi there, I'm Vikshut. In this video, I will quickly detail out the steps involved in using drones as a tool for surveying with an example of a project that we recently executed. Now, land surveying is a technique of determining the terrestrial or three-dimensional position of points and the distances and angles between them. To measure these, high-order GPS, robotic total stations, and terrestrial scanners have been traditionally used to map an area and make further computations. Further, surveyors have then used software such as CAD and GIS software to draft plans and map the on-site measurements. The outputs provide information to guide the work of engineers, architects, and developers. Over the past few years, drones have started to emerge as a prominent tool used in surveying. We have observed that using a drone can vastly reduce the time spent collecting accurate data. By acquiring raster data from the sky in the form of geo-referenced digital aerial images, with resolutions as sharp as 1.5 centimeters or 0.6 inches per pixel, you can gather millions of data points in one short flight. Large jobs that once took weeks can now be completed in just a few days, and a week's worth of traditional data collection is now achieved in just one day. We once conducted a survey of a 1,000-acre property in 5 days. 2 days on the field and 3 days of image processing and post-processing to generate all the outputs. This typically took 3 to 4 weeks to get done by traditional surveying methods. Also with drones, we can generate many different kinds of data that a regular survey cannot. 2D orthomosaics, color-coded digital surface models, extremely high-resolution contours that cannot be achieved through traditional surveying methods. The contour lines can be overlaid on the orthomosaic and the digital surface model, and a 3D reconstruction of the site. Drones make it possible to survey difficult and dangerous terrain where man and other equipment cannot reach. For example, steep mountain ranges, areas with no road connectivity, across water bodies, and dangerous sites like mines. A real estate developer required a survey to be done on a property to get the following outputs: boundary drawing, contours, and feature markings. All the above outputs needed to have a maximum root mean square error of 5 centimeters, both in terms of relative accuracy and global accuracy. The property owner was also keen to be able to visualize the property features to be able to make decisions on designing the project. Their first go-to tool was Google Earth. However, the satellite image was not of sufficient resolution for them to visualize the features accurately. Also, the satellite image was over 6 months old and seemed to indicate some differences in features as compared to the present status. This was when they contacted us to explore the possibility of using drones to take a video of the site. After understanding the requirement, we suggested to them that while an aerial video was one possible output from the drone, we can also use drones with ground control points as a tool for surveying, which can deliver all the survey outputs they needed, plus provide them visualization that they had not thought of before. High resolution 2D orthomosaic with the boundaries marked, 3D textured model of the site, and a digital surface model. The real estate developer was happy to try this technology out. So now, before going to site, the customer sent us GPS coordinates of boundary vertices in an Excel sheet. We converted these into a boundary polygon KML file and then into a flight plan with boundary extents further extended to ensure no part of the boundaries got missed out. We then worked out the positioning strategy of the ground control points. Next, after planning all this at our office, we went to the site. At site, the boundary vertices were marked with visible markers. This was done to be able to use them as reference to mark the boundary points on the final outputs. Ground control points were also marked, and the geo-coordinates of each point was measured accurately using a Trimble R8 base rover GPS system in post-process kinematics mode. The flight plan was executed and over 400 nadir images were captured. The ground control point coordinates were obtained using Trimble Business Center. The images were processed on Pix4D desktop, where the GCP MTP manager was used to incorporate the processing of the ground control points to generate the orthomosaic, the digital surface model, and the 3D model. Once we generated these outputs, we performed some post-processing on them to get them compatible with CAD and GIS software applications so that they could be seamlessly used by the clients. The DSM was visualized in QGIS. Contours were created and overlaid on the orthomosaic. Further, we generated 1 meter interval labeled contours and boundary drawings in AutoCAD. We also created a high resolution image of the site with the boundaries, north symbol, and the scale using GIMP. The 3D model was visualized in Sketchfab. When the outputs were delivered to the customer, they were satisfied with the accuracy and the utility of the results. The following aspects were most valuable to them. The contours overlaid on the high-resolution orthomosaic simplified the process of identifying how the contours run over the different parts of the property. Feature identification and marking became extremely accurate as the customer used the orthomosaic as the base layer to design the project. Since the boundaries were created using the visible markers, the exact area of the property was verified accurately. The DSM enabled the customer to identify elevations of various points at the site. This was helpful to get the height of the features like trees and rocks. The 3D model gave the customer a clear idea of the undulations of the terrain while helping them arrive at design decisions quicker. And most importantly, the outputs were signed off by a government certified surveyor as legal survey documents. So to conclude, a drone survey can generate all outputs that a ground survey can in a fraction of the time. It also can generate a lot more amazing visualizations such as 3D models, videos, images, orthomosaic overlaid on contours, DSM, and so on.